Hello, welcome to this lesson. In this video, we are going to learn how to solve systems of linear equations using Cholesky decomposition approach. Okay, so this approach says that if you are given a matrix A, which is a positive definite symmetric matrix, we can use a method known as Cholesky decomposition, and that is given as matrix A will be equal to a lower triangular matrix multiplying its transpose matrix. Okay, so let's look at how you are going to go about this. Okay, so assuming you have this system here, which is of the form AX equals B, right? Where A is the coefficient matrix, X refers um, to the column vector of the variables, and then B is the right hand side. Okay, so if I have this system here, okay, we know that we can write A as a product of a lower triangular matrix and then its transpose, right? So we can do a substitution here, and then we are going to have L times L transpose multiplying X to be equal to B. Okay, this is what you are going to have. So at this point, what I'll do is that I'll say that let uh, L transpose multiplying X be equal to Y. Okay, this is what you are going to have. So from here, if you do a substitution here, you are going to have Ly to be equal to B, right? Okay, so let's look at how you're going to go about these types of questions. Okay, so to go about these types of questions, what you're going to do is that first of all, you're going to solve for the column vector y using this formula here. Then after solving for the column vector y, you come and use it to solve for the variables x, which are the variables that we actually need. Okay, so this y here is just a column vector which will be given as y1, y2, y3. Okay, so if you're able to find this y, you can substitute it into this formula here. Okay, so you substitute it into this formula here rather, and then you already know what the transpose of the lower triangular matrix is. So all you have to do is to find the column vector x, which is given as x1, x2, x3. Okay, so you know that these are the values that you have to find, but before you can find this, looking at the step, you must first find the column vector y before we can come and find the actual variables that we need. Okay, so let's try an example to help us understand this better. Okay, so I'm going to write the system of equations in an a uh, in an a x equals b form, that's in the matrix form. Okay, I'll write this system of equations in the matrix form. Okay, so you are going to have something like you're going to have 3 minus 1 1. Okay, and then you're going to have minus 1 3 1, and then you have 1 1 2. Okay, and then for the x vector, you're going to have x1, x2, and then x3, and then for the right hand side, which is b, you have 2 6 5. Okay, so this is our a, this is our a, this is our x, and then this is our b. Alright, so you're going to change this matrix A into the product of a lower triangular matrix and then its transpose. Okay, and its transpose. Let's look at how you're going to do this. So we have A to be 3 minus 1 and then 1. Okay, and then you have minus 1 3 1, and then you have 1 1 2. Okay, so I'm going to change this to a product of a lower triangular matrix and then its transpose. So let's look at that. Okay, so for the lower triangular matrix, I'm going to have L11, okay, 0 0, and then I'm going to have L21, L220, then I'm going to have L31, L32, and then L33. Okay, so you're going to find the transpose of this, okay, which will be just changing the rows to columns. Okay, so let's look at that. So I'm going to have L11 0 0, then L21, L22, okay, 0, and then I'm going to have L31, L32, and then L33. Okay, so you're going to solve this so that you can get our lower triangular matrix and then also get its transpose. Okay, so let's look at how I'm going to do this. I'm not going to solve for all the entries. Okay, I'll do some and then leave the rest for you to do so that the process can be fast. Okay, so now let's look at what you are going to do. You're going to do a multiplication here. Okay, so I'll take the first row here. Okay, now multiply it by the first column. Okay, so that you're going to get the first entry, which is row 1 column 1 for the resultant matrix. Okay, so for this I'm going to get L1. Okay, multiplying L1, L1 multiplying L11 multiplying L11, and then I'm going to have 0 times 0, which will be 0, and then 0 times 0, which will be 0. So when you add everything up, you're going to get L11, L11. Okay, so let's do for the first row, second column. You're going to have L11 multiplying L21 plus 0 multiplying L22 plus 0 multiplying 0, and then you're also going to have row 1 column 3. You're going to have L11 multiplying L31, okay, and then plus 0 multiplying L32 plus 0 multiplying L33. So let's go to the next row. You're going to have row 2 column 1. So you're going to have L21 multiplying L11, okay, plus L22 multiplying 0 plus 0 multiplying 0. And then for the next, you're going to have L21, okay, multiplying L21, okay, plus L22 multiplying L22 plus 0 multiplying 0. So that was 0. And then, okay, so what I'll do is that let me write this value here, L11, L31, okay, and then let me claim this one here. Okay, alright, so for the last value we have row 2 column 3. So you're going to have L21 multiplying L31, okay, plus L22 multiplying L32, okay, and then plus 0, okay, and then we're going to have the last row, okay, multiplying the first column. So we're going to have L31 multiplying L11, okay, and then plus L32 multiplying 0 plus L33 multiplying 0. Then we're going to have L31 multiplying L21. You have L31, L21, okay, plus L32 multiplying L22, okay, plus L33 multiplying 0. And then last we are going to have L31 multiplying L31. Then we're going to have plus L32 multiplying L32. Then we're going to have plus L33, okay, multiplying L33. Okay, let me bring this here times L33. Okay, so let's simplify this. So when you compare this to the coefficient matrix A, okay, you're going to see that you're going to get L11 multiplying L11 to be equal to 3, right? And then when you simplify this, you're going to get L11, okay, to be equal to the square root of 3. Okay, so that'll be the first entry for the resultant matrix after the multiplication. Okay, so let's look at the next one. The next one also we have L21 multiplying L11, okay, and then this should be equal to minus 1, right? This should be equal to minus 1, okay, all right, which is this minus 1 that we have here. Okay, so we are going to have L21 to be equal to minus 1 over L11, which is what the square root of 3, right? So this will give us L21 to be equal to minus root 3 on 3. Okay, so I'll do it for the last entry so that you continue. So for the next entry, we have L11 multiplying L31. Okay, let me use this. Okay, we have L11 multiplying L31. Okay, so let's see, that will be equal to Okay, let me not do it that way. Okay, let me not do it that way. I considered okay, so I considered this first. Okay, and then consider this. Okay, so now let me consider this. Okay, I was using this, but that will not be uniform, so let's consider it column by column. Okay, so we have L31 multiplying L11. Okay, and then this should be equal to this one that I have here. Okay, so that will be equal to 1. You know the value of L11 already, so you have to solve for L31. Okay, this will be equal to 1 over L11, which is what? Root 3. So I'm going to get this to be root 3 on 3. Okay, so now after doing all this, okay, you're going to get your lower triangular matrix, okay, to be equal to root 3, okay, 0, 0, then minus root 3 on 3, minus root 3 on 3, and then 2 root 6 on 3, okay, and then 0, and then you have root 3 on 3, and then root 6 on 3, and then 1. Okay, so after doing this, this is the matrix you are going to get for the lower triangular matrix. So you just have to find the transpose of this matrix. Okay, so now let me free up some space so that we continue. Okay, so you are supposed to get the lower triangular matrix. Okay, so you have to do for the rest of the entries, that's the calculation where I pause. So you're going to have the lower triangular matrix to be with 3, okay, 0, 0. Then I'm going to have minus root 3 on 3, and then 2 root 6 on 3, and then we have 0. Okay, and then you're going to have root 3 on 3 again, and then root 6 on 3, and then 1. So this will be our lower triangular matrix. Let's find the transpose. Okay, so for the transpose, okay, we're going to have root 3, 0, 0, and then you're going to have minus root 3 on 3, okay, and then 2 root 6 on 3, and also 0 here. Okay, then you're going to have root 3 on 3, and then root 6 on 3, okay, and then 1. Okay, so this will be the transpose. Okay, so let's go ahead and apply Cholesky's method. Okay, so first of all, you're going to use this formula here where you have ly to be equal to b, right? So let's look at that. We have our L to be root 3, okay, 0, 0, and then we have minus root 3 on 3, okay, and then we have 2 root 6 on 3, then we have 0, and then we have root 3 on 3, then root 6 on 3, and also 1. Okay, so you're going to multiply this by the column vector y. Okay, so you're going to have this multiplying y1, okay, y2, and then y3. Okay, and then this should be equal to the right hand side b. So we have 2, 6, 5. Okay, so looking at this matrix that we have here, you can use forward substitution, okay, to solve for y1, y2, and then y3. So I'm going to have the first one to be square root of 3 multiplying y1 to be equal to 2. Okay, this is what we are going to have. Okay, and then when we do this, you're going to have y1 to be equal to 2 over square root of 3, right? Okay, okay, so this will be the same as 2 root 3, okay, on 3. So that's the value for y1. So let's find y2. So for y2, you have minus root 3 on 3, okay, multiplying y1, okay, plus 2 root 6 on 3, okay, multiplying y2, and this should be equal to 6. Okay, so now let's solve for y2. So you're going to have y2, okay, let me write this, 2 root 6, okay, divided by 3, multiplying y2 will equal to 6 plus root 3 on 3, okay, multiplying y1, which is 2 root 3 on 3. Okay, so now let's simplify what you have on the right hand side. We have 6 plus uh, root 3 on 3, okay, multiplying 2 root 3 over 3. So this will give us 2 root 6, okay, on 3 to be equal to 20 on 3. So now let's find y2. Okay, so I'm going to have y2 to be equal to 20 on 3, okay, divided by 2 root 6 on 3, right? So this will be equal to 20 on 3 times 3, okay, over 2 root 6. So this will cancel out this. So you're going to have 20 on 2 root 6. Okay, so this will give us y2 to be equal to 5 root 6, okay, divided by 3. Okay, so now let me write y1 here. Okay, we have y1 to be equal to uh, 2 root 3, okay, on 3. And then we have y2 to be equal to 5 root 6, okay, on 3. Okay, so now let's find y3. So I'll free up some small space so that we can continue. Okay, so let's go ahead and find y3. Okay, so we have for y3, you're going to have square root of 3 on 3, okay, multiplying y1 plus the square root of 6 on 3, multiplying y2, okay, plus y3, and then this should be equal to 5. Okay, so let's solve for y3. I'm going to have y3 to be equal to 5 minus root 3 on 3, multiplying y1, which is 2 root 3, okay, on 3, and then minus root 6 on 3, multiplying y2, which is 5 root 6 on 3. Okay, so now let's simplify this and see what you're going to get for y3. I'm going to punch everything at once. So we have 5 minus square root of 3 uh, on 3, multiplying 2 root 3 on 3, okay, minus square root of 6 on 3, multiplying 5 root 6 on 3. So this will give us a value of 1 for y3. So now let's go ahead and then use this formula here to find the x values, which is the variables x1, x2, and then x3. Okay, so now we have y3 to be 1. Okay, so at the end you're going to have our y, okay, to be equal to uh, 2 root 3, okay, on 3, and then 5 root 6 on 3, and then 1. Okay, this will be our y. Okay, so now let's go ahead and find the unknown variables x. Okay, so we are using the formula L transpose multiplying x to be equal to y, right? You know what L transpose is? We know it to be root 3, okay, and then minus root 3 on 3, and then we have root 3 on 3, okay, and then we have 0, and then 2 root 6 on 3, and then root 6 on 3, okay, and then we have 0, 0, 1. So this will multiply x, which is a column vector, so we're going to have x1, x2, and then x3, okay, and this should be equal to the y that we just found. Okay, so you're going to have 2 root 3, okay, on 3, and then you're going to have 5 root 6 on 3, and then lastly we have 1. Okay, so now let's find the value of x1, x2, and x3 using back substitution. So you're going to have 1 x3, okay, to be equal to 1. This means that you're going to get x3 to be equal to 1, right? So now let's find x2. So for x2 also, you're going to have 2 root 6 on 3, okay, multiplying x2, okay, plus root 6 on 3, okay, multiplying x3, and then this should be equal to 5 root 6 on 3, right? And we know x3 is 1, right? So you're going to have 2 root 6 on 3 multiplying x2 to be equal to this 1. So when I put 1 here, just the same. You're going to have 5 root 6 on 3, okay, minus root 6 on 3. So let's see what you're going to get. So we have 5 root 6 on 3 minus root 6 on 3. Okay, so that will give us a value of 4 root 6 on 3. So you are going to have this to be 2 root 6 on 3, okay, multiplying x2, and that will be equal to 4 root 6 on 3. Okay, so now let's find x2. I'm going to have x2 to be equal to 4 root 6 on 3, okay, times 3 over 2 root 6. Okay, so this will cancel out this, and then I'm going to have 4 root 6 on 2 root 6. Okay, this will give us a value of 2. So I'm going to have x2 to be equal to 2. Alright, so let me write the values here. x1 we don't know yet. x2 is 2, and then x3 is 1. So now let's find x1. Okay, so for x1 also, okay, we're going to have root 3 x1, okay, minus root 3 on 3, okay, multiplying x2, okay, plus root 3 on 3, okay, multiplying x3, okay, and this should be equal to 2 root 3, okay, on 3. Okay, this is what you are going to have. Okay, so now let's substitute the values. You are going to have root 3 multiplying x1 minus root 3 on 3 multiplying x2, which is 2, okay, plus root 3 on 3 multiplying x3, which is what, 1. This should be equal to 2 root 3 on 3. Okay, so now let's simplify what you have here. Okay, let's simplify that. So you have minus root 3 on 3 multiplying 2, okay, plus root 3 on 3. So that gives us a value of minus root 3 on 3. So I'm going to have root 3 x1, okay, minus root 3 on 3, okay, and this should be equal to 2 root 3 on 3. So let's take this to the right hand side. I'm going to have root 3 x1 to be equal to 2 root 3, okay, over 3 plus root 3 on 3. Okay, so let's simplify this and see what you're going to get. So we have 2 root 3 on 3, okay, plus root 3 on 3. So you're going to get square root of 3 x1 to be equal to square root of 3. So then we are going to get x1 to also be 1. So this will be the column vector x, which will be 1, 2, 1. So therefore, the value of x1 is 1, x2 is 2, and then x3 is what, 1. So this is how to use Cholesky decomposition to solve system of linear equations.